happy new year, a healthy, wealthy, prosperous new year. And having said that, let's go ahead and get started and dive into today's lesson. Today's lesson is DC circuit analysis, lesson number 14. We've given a diagram right here, and we have been asked to find this resistor right here. Okay, 240 volt DC source, and all we have is current which is flowing in this direction, and then we have the values of the resistor. So let's look at it for a minute and see, where can I apply KVL to find out, this unknown R, and then we have this I1 going down this way, I2 going down this way, that's also unknown, and then we have I3 going in this direction, I4 going down through the 4 ohm resistor. I drew these lines, circuit lines, based on educational or based on a guess, because if this 4 amp current is coming down here, it's going to split. So I3 is going to go this way and I4 is going to go across the 4 ohm resistor. Okay, so a little bit of assumption has been done. So now let's go ahead and see if we can apply a KVL at the outer loop where this red line is. So without any further ado, let's say KVL at outer loop. Starting from right here, the source is 240, so minus 240 plus, going from plus to minus, V is equal to IR, so it's going to be 5 times 4 plus, same current, 4 amp is going through 10 ohm resistor, so plus 10 times 4, okay, plus we have I4 going through the 4 ohm resistor, so plus 4 times I4 plus same current going through the 6 ohm resistor, plus 6 times I4 is equal to 0. Oh, that's a long one, huh? Okay, so let's go ahead and see if we can open it up. Minus 240 plus 5 fours are 20 plus 10 fours are 40 plus we have 4i4 plus 6i4. So that makes it 10i4 is equal to 0. All right. So if we simplify this, we will get 10i4 is equal to 180, and then I4 would be equal to 18 amps. Okay, so we applied the KVL at the outer loop and we were able to find this I4 current right here, but that's not enough. We need to do more. So let's say if we denote this as node A, all right, and we apply a KCL right here. So I get KCL at node A. Okay, 4 amp right here is coming towards the node, so that's going to be minus 4. This I3 is leaving the node, so it's going to be plus I3. I4 is leaving the node, that's going to be plus I4 is equal to 0. Okay, now we already know what I4 is, which we calculated it right here. Circle that with red. Okay, so then what we can do is we can just plug in the value of I4 right here, and if we do that, the I3 comes as minus 14 amp. Oh wow, so that's a good test. That's a good thing that we get this negative 14 amp. That means right here that my assumption that I3 is flowing this way is incorrect. In reality, I3 is going towards the node. Okay, but what I would suggest is don't change the direction of the arrow leave it the way it is, because this is going to help you solve the problem as long as you leave this I3 as negative 14a. Okay, so my suggestion is when you're working a problem and your assumption is going from right to left, but it turns out that you get a negative, so the current is going from right to left instead of left to right instead of right to left, just leave it the way it is. So now we have another unknown, which is I3 is equal to negative 14 amp. I'm going to circle that. Okay. So now what we're going to do is we are going to apply KVL at loop A. Okay. So let's say my loop is going to be, let's say this is my loop A. Okay. This right here. So I say KVL, Kirchhoff's voltage law, at loop A. This was at node A, this is the loop A. Okay. So when I do that, I get 4i4, okay, V is equal to IR, plus 6i4, all right, and then I'm going against the direction of the current. Okay, so I'll get minus 10 I sub 2, because I'm going against the direction of the current. And over here, it's going to be, I'm going against the direction of the current, right? So I am, in this particular case, my current is going this way, plus, minus. So I'm going to assume, and I'm going to just, use what I had before, my assumption. So I'm going to do plus 4 of I sub 3 is equal to 0. So remember this, when we assumed, I assumed that I3 is going this way. But when I solved for it, I got minus 14, which tells me the current in reality is going this way. But I'm going to leave it the way it is, because if I change the direction of this arrow, it's going to mess up the whole calculation. So we leave it that way. So once we solve for this, I plug in the value of I4 right here. I plug in the value of I3 right here. My answer for I2 is going to be 12.4 amperes. So now we have 3.